Welcome everyone. In this video I'm going to be introducing the Swine platform. I will be talking a little bit about the Smart Society, its components, and mainly its programming framework and the whole idea of the collective based tasks. I will be doing a little bit of a code walkthrough and a little bit of demonstration of the whole Swine platform. So in order to understand the Swine platform, we first have to look at the Smart Society. I have linked a link to this paper to this video. So basically, Smart Society is a platform where users can solve different social, collective, intelligent tasks, and the whole idea of the Smart Society platform is to blur the line between machines and humans. So in this platform we refer to machines and humans as peers because we don't make a distinction between humans and machines, and we solve tasks using a group of peers that is called a collective. So it is important to note that while we solve a task, we can only see the collective. We cannot see individual peers. So we can ask for a certain group of peers that fulfill a certain criteria. So for example, we can say we want all the peers that live in Vienna that have a certain gender and a certain age and so on and so forth, but we won't have access during the execution to the individual peers of this collective. And Smart Society furthermore introduces a programming framework, which we are going to be looking into a little bit more detail pretty quickly now, and some components. For example, it provides the peer manager, which is a central data where we store information about the peers. And also one of the components that it provides that we use in the Swine platform is called SmartCom, which is so to say a collective a middleware that is used to be that is used to contact the peers that are part of that are stored in the peer manager, so to say. Another paper that I'm going to be linking to this video is this one, which presents a programming model for collective based tasks. And to understand collective based tasks, I have saved a picture. Yeah, so basically we can imagine a collective based task like this. I'm not going to be going through this part of the diagram just because it is outside of the scope of this video, outside of the scope of the Swine platform, and whoever is interested into this part can read more about it on the papers that are linked to this video. So a collective based task is a task which uses collectives to solve tasks. So the whole collective based task has 4 different states. It can also have 3 different states, but it goes up to 4 states. So this state is not always necessary. The state is only necessary when we provide compositioning algorithms. So the first state would be the provisioning algorithm, and this state would provision all of the peers that fulfill a certain criteria that we gave. So for example, the criteria that we discussed a little bit earlier about having peers from, sort of say, Vienna who have a certain age, certain gender, and so on and so forth. And from this state, it goes either to the compositioning state if we have provided compositioning algorithms, or if it's not an open call and it is a direct call, then it goes straight into the negotiation part. Into this part, then we are going to be initiating negotiation with different collectives, and we're going to be reaching an agreement with one collective, which is then sent to then sent with a delay plan to the execution state, or it fails, or the negotiation process fails and goes into the failure mode. Now it's important to understand that each one of these states can go into the failure mode, but only the execution state can go into the success state. But these states are not going to go directly into the failure mode when they fail, because for each one of the states we provide adaptation policies, and we can have different kind of adaptation policies. One of the adaptation policies could be, for example, abort. So let's say this state fails, and then we check with the adaptation policy, and the adaptation policy then says abort the whole task. Then the whole task would go into the failure state. But we could also have another adaptation policy that says rerun the whole state, and then the whole state would be rerun again, and then we could use potentially incentive mechanisms to incentivize the peers of the collective of the state to agree, or well, not, it doesn't make sense to use incentivation in this state, but we can use incentivation, for example, in the execution state. We can use, in this case, we can rerun the state in this case, or we can also provide an adaptation policy that says use a completely another handler that provides another business logic. So we could also use that. So we don't directly go into the failure mode. We first check with the negotiation policy, with the adaptation policies, and then we see what it is to be done next after the state has failed. And one way how this whole concept could be improved would be by making by implementing the actor model. So we could use the actor model in the collective-based tasks by making the whole collective-based task as an actor, and then each one of these handlers would be then an actor child. So they would also be actors, and the communication would be done then using message brokers by sending to each other immutable objects. So this is the collective-based task, and these here represent the handlers. So it needs to, for each state, besides the compositioning state, because the state is optional, we are going to be having from one to multiple handlers. So whenever we initiate the task, whenever we initiate the collective-based task, then the collective-based task would create a child actor that runs the provisioning logic, and then whenever this child actor has finished executing or has failed, it sends a message to the parent, and then if it is a result, so if it has successfully finished executing, then the parent would kill this child, and then would go on to either the composition, and then would either create a compositioning handler child or a negotiation handler child, depending whether the collective-based task is a open call or not. In cases of failures, for example, let's say this child actor has failed, then the collective-based task would check with the adaptation policies about the provisioning state, and then it would either go into the failure mode, or it would try it and run one of the other handlers if the adaptation policy says so, or if the adaptation policy says so, and if it doesn't find another handler, then it ultimately goes into the failure state. Or the adaptation policy could also say rerun the whole process again, and then the collective-based task would send a message to the child, and then the child would try to rerun the task again, and then again it would either fail or succeed. So at any point during the execution of a collective-based task, this actor would be always alive, but only one of his children is going to be alive. So only the child that is in the state where the collective based task currently is running. The other children have either not been created yet or are already dead. And a platform that would use this functionality of the programming framework would be the swine platform. So in this platform, then we provide different components that are missing from the Smart Society platform. One of them would be a execution environment, so to say, where peers can create collective-based tasks, participate in collective-based tasks, or both create collective-based tasks and also participate in the solving of those collective-based tasks. The whole platform has REST endpoints, so different clients can be used to contact with the platform, but the platform also provides a web application that is built on React.js and that runs on a Node.js as a client to access the platform and its services. So basically the peers would either participate here or initiate tasks, which are then sent to the platform using REST requests. And then the platform has different kind of services that it provides. So the execution service would be for executing the collective-based tasks, and then we would have negotiation service, which provides negotiation mechanisms for the peers, where they can ultimately agree or disagree to participate in a task. And then the quality assurance, which provides mechanisms for the peers to rate the results of other collective-based tasks. And then we also have Piglet service, which we are going to be looking now, and also the peer service. So the platform uses a database, but the peers are not saved in a database, but rather it uses the peer manager sort of to see whether the peers have it uses the peer manager for authentication purposes, but also to initiate collectives and so on. It is important to note that the SmartCom component is a local implementation for demonstration purposes that only has one communication channel, and that is via email, because for demonstration purposes we are going to be using fake peers, and we are going to be sending them emails that are going to be running in our local host. And it also doesn't use the final peer manager, so to say, but it uses an implementation of the peer manager with an embedded MongoDB instance. So let's first run the client, and let's also run the whole platform. Let's go into debugging mode because I want to set breakpoints to see certain parts of the code base and how they're solved and so on and so forth. So first things first, as I said, we are going to be using a local mail service to contact the peers that don't really exist but that we have saved here. So I'm using some attributes, but other attributes can be used as well, so it's not necessary to use these attributes for peers. And then I load these peers, considering it's a demo, and I know that this is a demo from the attributes that I have in the application.properties file. And if it is a demo, then I read the peers from this file here, and then I save those peers the peer manager, and I also I save the peers in the peer manager using the peer service, because the peer service ultimately uses the peer manager, and then I create a mail, so to say, with their name, where and a password, and the password is just their name. And this is just for demonstration purposes, as I said. So I'm also going to be setting up. I'm also going to set up one local email address here, so whoever is interested knows how to set it up locally for demonstration purposes or for testing purposes. So we go then to the mail, and then we create the. Actually, I'm going to be creating two peers. Local host, and then. So I'm not just making up these peers. These peers are actually read from this list here, and then we create a local email address for them, so to say. So if I use a trivial name here or a trivial email address, it wouldn't work. So the password is again peer3, and we have to use a offset of 3000, and then we retest. Done. We understand the risks. We ignore this, and let's also create about the peer for peer. Yes, we understand the risks, and yeah. So now I have the email addresses of these peers here, and yeah, let's go to the client and log in. So this is the login page, and then let's try to log in with peer and peer. And again, the platform uses the peer service to save the users, and to also receive the users if they have been authenticated correctly. And the swine platform offers the idea of piglets, so to say, and each piglet then would consist of different collective-based tasks that potentially share similarities, but it doesn't have to technically. But it would make sense, for example, if I wanted to get, let's say, recipes from Austria, then I would create a piglet, and that's actually created. So let's name it recipes from Austria. A piglet consisting of different collective-based tasks that are going to be providing recipes from Austria. And so then we would have here the different piglets, depending on whatever the peer has created. And then once we go to the piglet, then we would see here all the collective-based tasks that are scheduled. They're in the provisioning state, in the compositioning, negotiation, executing, quality assurance, and the collective-based tasks that have finished executing. In this case, we haven't initiated any collective-based task because we just created this piglet. And let's create one now. So let's say recipes from Vienna. Let's say so this would be the task request that is going to be sent then to the peers. So let's say please provide recipes from Vienna, and then I can schedule it to start running not immediately. Let's say I wanna schedule it to start running it at let's say this point, and then we can here either make it an open call or a direct call. But since the swine doesn't implement the compositioning algorithms, it doesn't really make sense in my opinion to go through the compositioning state. And then we can provide here the timeout parameters for each one of the actors that represent the handlers. So for example, let's say for the provisioning state we would provide 10 minutes, 10 minutes, 10 minutes, and 10 minutes for the execution. So this if the handler needs more than 10 minutes, then the handler is going to fail and the whole collective base task is going to fail. And then here we are going to be providing the queries that are going to be giving us the results, so the recipes from Vienna. And in order to understand a little bit better what this part of the collective base task is, we have to first take a look at the new collective base task workflow. So the new workflow also introduces a new state, which is the quality assurance handler, and this handler runs after the execution handler has finished executing, and then it provides a quality of result number that is between 0 and 1, and then it sends that to the collective base task, and the collective base task then sends that to its parents, or whoever initiated the collective base task. And then it's up to the developers then to decide with that quality of result whether the execution of the task was successful, whether it was not, and so on and so forth. So one way how this whole problem can be solved, or how, let's say, how one way how this could be solved and how it is solved in the swine platform, is by introducing another collective base task for the quality assurance handler. So let's say this is the collective base task, and then the collective base task would also have other actor children for other handler states, and this is then the quality assurance handler. And then this handler also creates another collective base task that itself has 4 other children, because it is a direct call. We don't have to go through the compositioning state. And this collective base task then has as I said, 4 different children, and once these tasks have finished executing and the whole execution, let's say, has been successful, then we send the result from this collective base task to the handler, which is its parent. But the collective base task does not know that it is a child of another handler. It just sends the result to the parent, whoever initiated this actor, and then this quality assurance handler then sends the result back to the collective base task. And as you can see with this model, we can recursively create as many collective base tasks as we want, and we can have a nice tree structure, which in my opinion is way more flexible than the previous model of the collective base tasks. So then this part is about creating the other collective base task, and let's say we provide here the parameter for solving the parameter from the parameter that provides the bare minimum quality of result that the task needs to provide in order for it to be considered successful. So let's say we want it to be 0.6, the quality of result, and let's say then we want the peers of the collective that is going to be solving the quality assurance to be from Wells. And we can also, for all of these, create dynamically peers. And let's say another parameter that I want to give is the role, and let's say the role is a tester. I actually this wouldn't be then scheduling, because we already passed the